Hey everybody, hope you're doing well. Here is our video for today. We're actually going to be in our problem solving notes for today, and here's our first page. And today we're going to put together all of the equation work we've done in the last week and put it all together to solve some of these more challenging problems. So today's going to have a lot of geometric figures in it, so we need to make sure we remember what perimeter is and think about all the different ways that we can think of an expression versus an equation and how they're the same and how they're different. But anyway, let's get into all of this. Here's our first problem of the day, and it deals with this equilateral triangle. So we have to remember anytime I have an equilateral triangle, what does that really tell me? Well, that means all three sides of that triangle are the same length. And we see that with this picture over here. It has all three sides being this expression d plus 5. And it merely asks us to write two different expressions for the perimeter of a triangle. Remember, perimeter of a triangle just says I'm going to take this side and I'm going to add it to this side and I'm going to add it to this side. That's perimeter, adding up all the sides. So in the first expression, or for question 1, it says simplify expression number 1, right? And it's referring to this right here. So if I want to simplify that, I think I need to combine any like terms that I have. All right, so I can add up all of my d's. Those should add up to 3d. I then can add up all of my constants, all of our numbers. 5 plus 5 plus 5, that turns just into 15. That's one way to find perimeter, right? We add up all the sides of the triangle. Adding up the same side, right, on an equilateral triangle, when it's the same number, well, repeated addition could also be expressed by multiplying. And so that's where expression number 2 comes into play. So if I wanted to simplify this expression here, that just tells me use distributive property. So here's our expression 3, and we're multiplying that by this quantity d plus 5. So that is going to turn into 3d, right? 3 times d is 3d. 3 times this positive 5 is just 15. There we go. What do we notice about these two expressions from number 1 and 2? Well, in fancy math words, we could say, right, the two expressions are equivalent. Or my handwriting is not that great. The two expressions are equivalent, right? Equivalent is a word you're going to see a lot of, right? That means they are equal to each other. All right, they're the same thing. They might look different initially, right? If we look back, our two expressions, right? They don't look very much alike. Here's our first expression right here. Here's our second expression right over here. They don't look alike, but once we simplify them, they do actually turn into the same thing. So let's see what else it wants to know. Jessica has taken the expression from number 1, and she's written it, all right, just like she has here, with all the d's together and then all the 5's together. Why might she have done this? Well, I think she did exactly what we did, right? First off, I think she just combined like terms, with I just abbreviate as CLT. So she combined like terms, which is completely acceptable to do. Why might she have done this? Because that's really, if I want to simplify this expression, I can't add non-like terms, so our only chance is to add these, right? So she basically grouped, all right, the like terms. Question 5 wants to know if her expression is equivalent to expression number 2. Well, if we look at her expression here, if we really did combine these like terms, right, again, she grouped all the d's together, then she grouped all the 5's together. Well, if we were to add those up, yeah, those turn into 3d plus 15. So is that equivalent to the expression in number 2? Absolutely it is. Yeah, it's the same thing. Remember, we just talked about, hey, we can have the same thing. It can just be written a couple different ways. All right, so let's flip over here. Next page. And we're going to talk a little bit about rectangles, and more particular, we're going to talk about perimeter of a rectangle. All right, so let's, if I zoom in, I'll have better handwriting. I promise to do better. The lengths of the sides of the rectangle are shown. Write two expressions for the perimeter. So again, here's our sides. In a rectangle, opposite sides are equal to each other, right? That's why these two are the same thing, and that's why these two are the same thing. So the first way I can write this, perimeter, just says add up all your sides. So the first way I could write this is just to say, hey, t plus t plus 3, right? There's that side and that side. Let's add the other two sides in, t and t plus 3. So there's one expression. If I simplify this, which we certainly can do, we can add up all the t's. That turns into 4t. And add up your numbers. We had 2 3's, so that'll turn into 4t plus 6. So that's one way I can write it. A second way to write it is I've got the same side twice, right? Here I have the same side with this side. So I could just say, hey, multiply 2 by one of those sides. And then we're going to add that to, well, I've got the same side again here twice. So let's multiply 2 times one of those sides, t plus 3. Again, if we wanted to simplify this, we most certainly could. 2 times t is just 2t. Distributive property here, so if we distribute that, that turns into 2t plus 6. And then we could combine those terms together, and we would get 4t, and nothing combines with the 6. Right? And again, here's our two expressions, 4t plus 6. We got them from two different ways. Good news on number 7. All right, we are going to skip this. This is talking about factoring, which we did last year in 7th grade. Factoring, some of us think of it as dividing, and I'll show you a factoring one here in just a little bit. But let's look at question number 8. All right, question 8, again, here's that fancy word for today, equivalent. It wants to know how we would figure out, how would we determine whether this expression here is indeed equivalent or equal to this expression over here. Okay, are they equivalent? Well, I would say let's simplify both of these expressions. So I'm just going to put one of the expressions, I'll put the red one here on the left-hand side, and I'm just going to try to simplify this as we go. And then I'll put the other expression on the other side, and we'll see if they are indeed equal to each other, right? Equal to each other means they should be the same thing. So first things first, distributive property here. Negative 3 times a positive 2, p just is negative 6. All right, negative 3 times a positive 4, negative 12. Let's go ahead and combine like terms. So numbers combine with other numbers. All right, variables combine with variables. Watch your signs, right? Keep the sign, keep the symbol. 18 minus 12 turns into 6. Negative 6p minus another 3p, negative 9p. So there's the left-hand side. Now let's see what this right one turns into. I don't think it's nearly as complicated. And this is not the only way to do this. We could have factored and done that. That's why the other question wanted to factor, but I think it's easier to stick with what we've been doing in class. So let's just simply distribute, all right, this 3 into both of these. This turns into 6, and this turns into negative 9p. So now we have to answer the question, are these expressions equivalent? And we can say without a doubt, yes, they most certainly are. If I can write, there we go. They definitely are, because we have the same thing. Okay. Good news for you guys. We are going, all right, due to time constraints, we're going to skip number 9. But don't worry, these are the last ones we're going to skip. And we're going to move on to question 10, because we're going to spend a little bit of time here, because this is one of the harder questions of this whole packet. Again, we're talking about perimeter. This time we're talking about perimeter of a square. It didn't give me a square, so just because I'd like to, I'll write a square there. Remember, if I know one side length, so if I know this side length here on a square, I know all of them because all the sides of a square are the same length. That is not what this question wants me to do, though. It says the perimeter of this square is represented by this expression right here. This expression that looks like it repeats itself. So 8x minus 10 plus 8x minus 10. And it says write an expression to represent the length of one of the sides of a square. Well, perimeter is found by adding up all four sides of this triangle. So for starters, let's, I suppose we should probably combine this expression down and simplify it. So like terms would say your variables will combine. All right, your numbers will combine. Watch the symbol or watch the sign that it's with. 8x plus 8x. That turns into 16x. Negative 10 minus another 10. Well, that's just negative 20. So this is all this says really is that this 16x minus 20, right? This is the perimeter, right? Or if we added up all four sides, right? Here's a side and here's a side. So we add up all four sides and it adds up to this weird expression right here, 16x minus 20. But the question just wants to know, well, what does one of these sides turn into? Well, we again have to use the knowledge that all of the sides of the square are the same length. I know all four of them turn into 16x minus 20. Well, if I want to know what one of them is, I need to take this expression and I need to divide it by 4. So, and I'm not just dividing one term. I'm not just going to divide this term or that term by 4. I'm dividing both of them by 4. So really, we can think of it as 16x divided by 4. And then I've got this negative 20 that I'm going to divide by 4. So when we do that, this turns into 4x, and 20 divided by 4 is just that 5. Well, it's going to be a negative 5. So there is the expression for one of the sides of our squares. So again, we have to combine a little bit of our geometry knowledge about squares to go along with that. 2 more pages and you're done listening to me yap about everything. So here's our next one. So it wants me, it says solve this equation, right? And then it's gone through and right, it solved that equation for us, and hopefully, we could do that on our own if we needed to. But question number 1 says check the solution. Right, so here's the solution. I got negative 2. Check the solution by replacing n in the original equation with negative 2 and evaluating both sides. Right, in equations, we're always talking about the two sides of the equation that we have. So I'm going to do all my work over here because I need some room for this one. So one side is 4n, right? The other side is, and just for time constraints, I'm going to use this side right here, the n minus 6. Okay, and remember, in an equation, all it tells us is that the left side is the exact same thing as the right side. They don't look like it because they're expressions, right? I've got the expression 4n and the expression n minus 6. They look different, but all an equation says is the left side stuff is equal to the right side. If I want to check that, well, we can, right? All we do is take our answer here, which they found negative 2, and then we are going to substitute negative 2 into our equation, right? This is our original equation right here. Everywhere that I see an n, so right here and right here, I'm going to plug in the number negative 2, and then I'm going to add, subtract, multiply, whatever I need to. So the left-hand side says, hey, 4n, or 4 times n, so that's 4 times negative 2. and I want to know if that's going to be equal to negative 2 minus 6. I have no idea, but let's keep going here. 4 times negative 2, negative 8. Is that equal to negative 2 minus 6, right? That's the same as adding the opposite, so plus negative 6. So lo and behold, it is, right? Negative 8 is equal to negative 8, right? Any number is always equal to itself. So what true statement do we get? Well, I get the true statement negative 8 is equal to negative 8, right? We're able to do that. Even if it just said, hey, is negative 2 a solution? This is all the work we would have to do, guys. So now we might have to start from the original equation, right, and distribute and do all that, but we could still do that. I lied to you guys. Good news. We don't have to worry about why we would get rid of the fraction, right? We can save that for a while. Instead, let's look at number 3 here. I love these questions, right? Figure out where they made a mistake. So Trey solves this equation right here, and somewhere along the way, our friend Trey has made a mistake. Figure out his error. So if you want to, guys, pause the video, see if you can't figure out. Here's all of Trey's work over here. Figure out where he went wrong. He actually did a couple things wrong, but let's talk about the first error that he made, and then let's solve it right. So pause that, come back, and then we'll do both. Okay, I think if we just go through, if somebody tells us, hey, we made an error somewhere, well, we might as well solve it on our own and then see where we differ, and sometimes that's an easy way for us to figure out where the error really occurred. So step 1, distributive property. So I'm going to distribute 1/4 into both of these terms here. 1/4 times 8x is just 2x. 1/4 times 16 is just 4. All right, I didn't do anything with the right-hand side. It's just equal to 4x. Now we need to solve this. So we need to move all the variables to one side, all the numbers to the other side. I think it's a good practice if we move this variable 2 over to the other side. When I move to the other side, we have to do the opposite. So this is a positive 2x, so the opposite of that was a negative 2x, or subtracting 2x. Left-hand side, it cancels out. We're just left with 4 being equal to 4x minus 2x, all right, which is just 2. Last step, divide by 2, divide by 2. And 4 divided by 2 turns into a pretty decent number, turns into 2, which is our right answer. Let's see what our friend Trey did. I see a couple mistakes he made. First mistake is right here. He did not distribute 1/4 into 16. 1/4 of 16. This number really should have been a 4 like we had. Then you'll notice it looks like I think what he's doing here, he's taking this 2 and he's dividing both the 16 and the 2x by 2. Maybe it looks like he did that, or maybe he subtracted that over. I'm guessing that's what he did. But his second mistake, though, should be, right, if he has this minus sign here, which I can't even see if that's a minus sign anymore because I've written it in blue. I think it actually might be a plus sign. He should have had that still as a minus sign. I think it's a plus sign, though. Anyway, his first mistake, though, distributing wrong. So distributive property, again, be careful with that. Let's hop over here to our last page. Only a couple more minutes, and then you'll be done listening to me for a while. Describe the first step we would take to solve this equation. So first step I would take to solve this equation. Again, if you know it, pause the video and try it out. So first step I would do, combine like terms, right? I've said it before, you know, combining like terms, always a good idea. So I've got a variable here and I've got a variable here. So I'd like to combine those together to have 20 equals 7y minus a y is just 6y, all right, plus 2. Is that the only thing that we could have done? No, that's not the only step. that we could have done, right? Not in the least, right? So okay, so there's one way. Here's another way. You know, if we leave the variables just like they are, I could have, you know, okay, I know at the end I'm going to get all the variables onto the right side here, and I know all my numbers need to go to the left side. So I could move 2 over here to the left side, right? That's a very acceptable first move. I could subtract 2 from both sides. 18 is now equal to 7y minus y. Okay, that works out just fine too. So either of those steps are just fine. Again, it didn't ask me to solve it, so we're not going to solve it. If you want to, though, feel free. Go right ahead. We are going to move on, though, to question number 5. Now, this question says to solve the equation in 2 different ways. I'd just like to solve it in one way. All right. Again, there's always more than one way to handle something or solve something in math. But for today, and due to time constraints, because we're already at 21 minutes, let's just solve this like we normally would. Distributive property gets to go first. Okay. Distribute 0.6, so 6/10. We're going to distribute that into both, and this should turn into 3p. And let's see, we're going to take 0.6, multiply that by 15. I believe that should turn into 9. Let's move our variables to the left. So let's subtract 3p. Let's subtract 3p. Cancels out here. You're left 3p being equal to 9. Divide by 3, divide by 3. Our solution, right, our variable, is equal to the magical number of 3. Here we go. Save the best for last. All right, here's what we got, guys. Perimeter. It says 2 rectangles shown below have the same perimeter. Write and solve an equation to find the value of x, then find the measures of the length and width of rectangle B. All measurements are in inches. Okay, so it's telling me the perimeter of rectangle A. Again, perimeter isn't just 2 sides, it's not 3 sides, it's all 4 sides here. I know this side is a 7, I know this side is a 5. If I figure out the perimeter of rectangle A, well, I'm going to add up all of these sides. Right? 5 plus 5 is 10. 10 plus 7, 17. 17 plus the other 7. So I know all of these have a perimeter of 24. It's telling me that these 2 rectangles, right? Here's rectangle A, and it's also saying rectangle B. These 2 rectangles have the same perimeter, right? They're equal to each other. I don't know what numbers rectangle B has. I just have, again, these expressions. I know this side has to be an x, just like I know this side has to be a 4x minus 3. If I add up all of these x's, again, combine like terms, x plus x plus x plus x, right? We can write all that out. X plus x plus, here's 4x minus 3. Here's another 4x minus 3. So there's the perimeter for rectangle B. If we combine like terms, add up all your x's. So 1, 2, 3, all 4 of those terms have variables in them. So we're going to add all those up. I get 10x. Let's add our constants up, negative 3 and negative 3. So negative 3 minus 3 is just a negative 6. So here's our 2 perimeters right here. One of them is a decent number in 24. The other one is this expression, 10x minus 6. It wants me to figure out eventually what's the length and width of this rectangle. So here's what I'd like to do. Let's set these 2 equal to each other. So my equation looks like this. 10x minus 6 is now equal to 24. All that says is rectangle B is equal to rectangle A when we're discussing their perimeters. Let's solve this equation for x. Alright, so here's your 2 sides. I don't need to move my variable. We can move 6 over here. So we're going to add 6 to both sides. Alright, we're left with 10x being equal to 30. And divide by 10 on both sides. X is equal to 3. All right. Our equation, guys, this was right here. Right? So here's that equation. Now it wants to know the length and width of the rectangle. So all we have to do is substitute our answer, right? We just have to take 3 and plug it back into this expression everywhere we see an x. Do a little bit of multiplying and subtracting. And again, take your value. Don't have to do much here. All right. The width, right? If we think of, okay, here's your length and here's your width. Well, the width is just x. Well, that's just 3. The length is this 4x minus 3, or 4 times 3 minus 3. So 4 times 3 is 12. 12 minus 3 is 9. So there you go. So this rectangle is 9 by 3. And there you go. So here's what you guys get to do now. Here's the fun part. You get to stop listening to me, which is fantastic. And on the next 2 pages, 145 and 146, all right, you see 5 problems there. So your homework for tonight is to work on those 5 problems. Okay? Enjoy, rewatch the video if you need to, or if you're bored and can't sleep at night. Surely this will help. All right? Have a great day, guys.